How y'all doing tonight? My name is Yotam. I'm one of the head organizers of the expo, and it is my truest honor to present Sagi. He's the CEO of Percepto. Batteries ran out. Anyways, he's the CEO of Percepto, CTO of Percepto, a company he helped found back in 2014. And he completed his undergraduate studies in electrical engineering and physics at Ben Gurion University. And, it's truly an honor to have him. So, without further ado.
Thank you. You did your homework. I'm very excited to be here. It's actually my first time in Technion, somehow. I'm a co-founder and CTO of Percepto, and I'm gonna talk about a little bit about the company and another few minutes about what it meant for us to deploy autonomous robots in our client sites. So a little bit about Percepto. We started like 8 years ago. Started out with integrating real-time computer vision into the control loops of drones. That was our core competency. We've developed the Percepto Core, which is a small model based on NVIDIA, which allowed us to run computer vision in real time and to have that computer vision the input for a control loop of the drone. So it was something that was haven't been done when we worked on it. Obviously now it's like common practice. Since then, we've built around this technology our first drone-in-a-box solution, which is a drone-in-a-box, and I'll show you if you don't know how it looks like. And we're providing with this drone-in-a-box solutions for inspection and monitoring of infrastructure and facilities for sites that are heavy on infrastructure. So usually heavy industry like power plants and mines and refineries. Our solution is awarded in the industry and in the media. And we are reaching a scale of deployments right now. The last year or year and a half is our first real scale of deployments. So now I'll let the client speak.
Hello from Canada, eh?
Hello from Percepto, Australia.
Hello from Africa.
Hello from Chile.
Hello from Germany.
Hello from Israel.
Hello from Mexico.
Hello from the United States of America.
These drones in a box are online 24/7, ready to fly at a moment's notice.
We're able to quickly deploy this instead of charging batteries, getting all of our gear, traveling to the site.
It's so simple, we don't need to think twice about deploying missions.
To be able to see our infrastructure in areas where we can't get to safely, to quickly fly over it and understand what our conditions are.
We get thermal imaging and infrared imaging, so we can actually see the tank levels and see for any anomalies within the pumps and the housing of the pumps and stuff as well.
Instead of sending somebody out on icy ladders or putting them up in man lifts or those sorts of things, let's go ahead and have a robot do it.
It also creates value for us in that the people that used to have to do that now are freed up to do higher value activities.
Anyone in any location can watch the missions.
The stakeholders themselves can see those changes and see the different reports and know that it's correct every time.
Increase our reliability and continue to keep our bills as low as possible.
It just gets people connected to the important information to help make right decisions and to keep people safe. And the quality of information is just so much higher than you would ordinarily have.
I see it playing a huge part in the future.
We're already addicted to it.
Oh man, it's going to be a pretty awesome ride, you know.
It's not just a dream. It's actually, the tool can come in and can actually help us add value day one.
Nice. What I like about this video, it's these are not actors. It's the first time it's not actors for me. Real clients. We did cut out all the bad stuff they said about the system. There are bad stuff. But for now, to better understand their pain, we'll start with the drill. Can anyone spot what has changed in this pipeline? A little bit tough. This may be the start of a leak, and leaks tend to grow to a failure in infrastructure. Another one. This one is a little bit easier. There's a phase in a transformer that's heating up, and if we don't identify these failure soon enough, we're going to have a whole other event to deal with. So, to better explain the problem, we are so reliant today on our infrastructure that any fault that cause a break in service has tremendous influence on our lives, on our businesses, our facilities, and still many faults happen. And why is that? Because we scaled our infrastructure so much without the right tools to monitor it. Almost all of today's infrastructure inspection are done by human labor, and this is inconsistent, it's infrequent. There is a serious problem of getting the right professionals to do that, and at a lot of cases it's also dangerous. And so companies that hold these facilities and infrastructures have no means to monitor their assets, and they tend to react to faults instead of preventing them. It's a well-known problem, a very public problem. This is President Biden last year signing a $1 trillion bill to try and fix infrastructure across America. Very good for Percepto. And what we help these companies do is transform the inspection process from this to this. This is the main screen of our cloud software, which shows potentially all of the issues of your infrastructure in your site. So this is valuable enough as is, but when you power it and make the data collection automatic using autonomous robots, it gets really, really efficient. That's my sales pitch for now. Okay, so I'm gonna talk about what it's like for us, what it was like for us to deploy autonomous robots in the field, and I'm gonna use this version of stages of autonomy, but I'll dance around it. So this is how we met the market. Inspection was done by professionals using a notebook in the field, completely unscalable. And as we started with around the time where drones became available from an economical point of view, and they did start using drones to reach difficult or dangerous places for inspection. However, while they reduced the amount of professional inspectors needed to inspect infrastructure scale, they added a demand for expert pilots, which proved completely unscalable. This also improved the data, and we've seen this when the drone technology advanced and the DJI drones became more popular because they held some assistant piloting functions. I'm sure you all know right now, if you buy a DJI drone, you can completely program it to do its mission, and all you had to do is get it out of your car, turn it on, and hit launch. And if everything is okay, it will do its mission, collect its data, or whatever you want it to do, and return and land nearby. So that's what these companies did. And it did help a little bit with the demand for expert pilots because it lowered the barrier for piloting. But still, it was unscalable because you have to have a certified pilot on the field to mitigate the unexpected. Okay? So when you're on scale, you don't deal with a solution that is 95% operational. Okay, 95% for me, it's 1 or 2 failures per site per day. It's unacceptable, it won't work. So these drones and later ground robots did improve very much the consistency and the quality of the data for inspection, which is done in the back office by professionals until AI gets into the play. And for ground robots, while piloting is less challenging, the environment is much more challenging. Navigation is much more challenging on the ground than on the air. GPS is not enough. Half a meter of error means you're either on the stage or off the stage. It's critical for an inspection mission. And so what we need for solving the automated navigation of ground robots is something better than GPS. So most companies use some kind of LiDAR sensor, which is still very expensive and unapproachable. And others use visual markers that are combined with computer vision algorithms such as SLAM to navigate. But still, this is considered an unsolved problem since, again, even if you're at 99%, if you need once or two times a day for an operator to come to rescue the autonomous robot because it is stranded, then you're not ready for scale. So for us, the big announcement for the market was our first drone in the box. Drone in a box means the drone can repeatedly go out, execute missions, come back, land, offload its data or upload the data, charge, get ready for the next mission, and go again. The target here is to have at least several days without any human intervention. So for this to work, the most dominant technology barrier is the precision landing. Okay, we want to land on a landing pad. For us, it's less than 1 meter square, and we want to do it night and day, windy, stormy, rain, whatever.
What's it like to learn math on Brilliant.org?
We have an ad.
Brilliant gets you hands-on to help you learn by doing.
So what we did, we've developed an addition to usual computer vision-based precision landing, which is 90% of the cases is based on an IR beacon with an IR camera. Very simple, yes, but not good at wind gusts. If you'll see how the drone actually manages its descent with very gusty weather, you'll see our advantage. So what we did is added markers all over the pad. This is not us. For which, if the drone sees only small parts of the pad, it knows how to continue. So, different from solutions that are based on GPS or IR beacons, if the drone comes close to the pad and then gets a wind gust and it is pushed a few centimeters to the right, when it's very close, it means the beacon is out of the image. So, just as an example of things we had to develop to make sure the our autonomous cycle is stable, we added markers all over the pad, so it only has to see a small part of the pad for the landing to continue and not start over. Another example is a parachute. This is not me. That's a nice video. Okay. Parachute, right? So, as we accumulated tens of thousands of flight time and work out all the kinks and made our solution stable and prolong the time between human intervention is required, still faults can happen. Even if you have a 99.99% solution, faults can happen. And when if we need to deploy machines, autonomous robots on site, you see, like this facility with very sensitive infrastructure, we want to make sure we do no harm. And for that, we had to develop a parachute. So, another video. Let's try again. Okay, so you've missed the parachute video. We developed the parachute. The parachute goal is to reduce the impact of the drone. The drone is lost by that point. If one of the engine fails or the battery failed, the drone is lost. Saving the drone is not the goal. The goal is save the infrastructure below the drone or any humans, obviously. So, by the way, this, I think, it's recorded, but I think it's only happened once for real. It happened many times in testing, of course. And my point is, even though you have a solution that works, you feel like it works, nothing is 100%. And you always have to develop more mitigations, more safety layers for the robots, especially if they work in such a hazardous environment, such a risky environment, and you have to communicate safety to your clients. Okay, so Once we had the fleet of autonomous robots working, and with long enough between human intervention, it was time to get the inspection and monitoring of facilities really autonomous, which means in our vision, it's not remotely operated anymore. It's just, it operates without any humans behind it. So that's where Percepto is now, and that is how some sites already work, and we keep developing more and more features like collaboration between the robots, having the robots learn from what the other sees and let them know what to expect when going to inspect, what to expect when inspecting an asset. These are all stuff we already do, which is not necessary for fully autonomous operation. What is necessary is regulation. And unfortunately, while Percepto is at stage 5 of autonomous inspection and does so in a few sites, most of the world regulation is stuck at stage 3 and enforces us to have an on-site certified pilot with line of sight of the drone. So our scale in a lot of the geographics is limited by the thing the word called BVLOS, which is beyond visual line of sight, and it's a certificate from the authorities that we can operate the drone without any pilot present in the site. Percepto works with all its effort to progress regulation, mostly in the US, where we sit in several federal committees, and we try to influence how autonomous robots' future is going to look like. And for now, 2 months ago, FPL, which is Florida Power and Light, announced that they're going to deploy a Percepto system in every electric substation across Florida. That's around 700 systems of autonomous robots. It's a process that's going to take a few years. We're going to solve all the regulation kinks while we do it, now that we have a very strong partner in Florida. And that's it, I think. If I have time for questions, I'll be happy to hear. We're not doing questions, so catch me later. Thank you.